today our topic is net ionic reaction. So here is the agenda for today. We'll have a brief introduction of the active components, what's the definition of it, and then I will have a brief introduction of how to write the net ionic equation. The final part will be the practice by yourself. So just to refresh your mind, that we have previously learned about how to predict the final products by the double replacement reaction. Right? It's simply just the exchange of the cations and anions of the reactants in a solution. But how do we know that the chemical reaction actually happens? In order to answer this question, hopefully you remember that from the previous class we mentioned about the chemical driving forces, including the formation of water, H2O, and the precipitate, and also the non-ionic compounds. So for those chemical reactions that actually takes place, we should be able to identify the active components in the ionic equation. The active components here means the ions that actually participate in the formation of the chemical substances. Here I take a simple acid-base reaction as an example to see the active components. First of all, I want you to predict the final products of the hydrochloric acid and sodium hydroxide based on the double replacement reaction. So we can see that the water will be formed because this is the strongest chemical driving force. And then the sodium chloride will be formed in its aqueous form, right? So if we write the ionic equation, which is obtained by writing all of the soluble ionic compounds as ions for this reaction, the hydrochloric acid will be in the form of hydrogen cations, right? And its chlorine anions. And then sodium hydroxide will be in the form of sodium cations and hydroxide anions. And then in its final product side, we will see the formation of water, liquid form, and sodium cations and chlorine anions, right? So if we take a closer look at this reaction, we can actually cancel the chlorine anions here, right? And then the sodium anion cations. So you can see that the hydrogen and hydroxide ions are left to form the water molecule here. So we can say that in this reaction, the hydrogen and hydroxide ions are the active components of the acid-base reaction. The net ionic equation will be the combination of the hydrogen ions and the hydroxide ions that forms the water. In order to let you have a deeper understanding of the chemical driving forces, can you write the active components of this reaction? In this case, the precipitation is formed. Here, the BaSO4. You can pause for 1 minute to practice on your own. Alright, let's have a look. In order to know what ions participate in this reaction, we have to first write out the ionic equation for this reaction. So in this case, the potassium ions here and the sulfate ions are existed in the potassium sulfate solution. And then the Ba2 plus cations and the nitrate ions here, right? And then they form the precipitation of BaSO4, and then the potassium cations and nitrate ions. So this is the overall ionic equation. Let's take a closer look at this ionic equation. We can actually find that the potassium ions here can be cancelled, and also the nitrate ions, right? So you can find that the sulfate ions and Ba2 plus ions are the ions that actually takes part in the BaSO4. So its net ionic equation will be sulfate ions and Ba2 plus aqueous form and forms the BaSO4 solid. and we can tell that the sulfate ions and Ba2 plus ions are the active components of this reaction. Alright, hopefully you have known how to identify the active components of the ionic equation. Also know how to write a net ionic reaction. See you next time.